This is Ruth Guthrie, and I'll be giving a simple overview for databases. This is intended to refresh your understanding of the database tutorials you have already read through. The classic example always given as an example of a database is a file cabinet. This is done because you're supposed to learn better if you have a concrete mental model that you already understand and can relate databases to. Have you ever been to a doctor's office and seen all the files kept in back at the nurse's station? When your name is called, typically your file has been pulled and the nurse carries it with her when she goes to take your vital signs before you see the doctor. The folders for each patient have colorful numbers on them, and there is some kind of filing system to keep track of where your medical history is located. More and more, these files are being moved to online repositories. But think of that giant wall of files or a file cabinet as a database. Each file is a record containing data items such as last name, first name, medications, date of your last physical. These data items are kept for every single patient. Student records at the department or in Bronco Direct are very similar. The database is all student information. Tables might be classes, payments, transcripts, or student information. Records for student information include the data items Bronco ID, of course, first name, last name, email, enrollment date, etc. for each student. It is a logical way to form the data so you can understand it, extract data, and relate the tables together. Here's an example. Each orange box represents a table. All the items contained in the orange box are the data elements. Under student data, we've got Bronco ID, name, address, etc. Every record in this table has these data items. Under enrollment in winter 2013, I see what classes students are enrolled in. Every Bronco ID in this table has up to 8 classes they are enrolled in. I'm not sure what the limit is in real Bronco Direct, but if you took several one-unit PE courses to keep your financial aid, you might end up with many classes. The table classes in winter gives us the characteristics for each class, such as department number, class name, units, time that the class meets, and the professor's name. We can find out what student is enrolled in each course by linking these tables together. We know how they are related because of the unique identifiers in each table, like Bronco ID and class number. At Cal Poly, a class number is often called a CRN number. If Paul Smith has the Bronco ID 123456789, and I want to see what he is taking in winter, I have to link the student data table to the enrolled in table. I do this through the Bronco ID, which is also known as the primary key. Wikipedia defines a primary key as a key that uniquely defines the characteristics of each row. But think of it as a unique identifier to keep things from getting mixed up. You wouldn't have 2 different people with the same social security number, for example. Other unique identifiers that you would see in a database are product ID, ISBN number, employee ID, any number or code that is unique for the records you are trying to manage in the relational database. A relational database is a set of logical tables that link together to contain data. A relational database management system provides a software interface that makes it easier to enter, access, and report on the data. These are a few RDBMSs that you might have read about or heard about in the news. Access you may have actually used in CIS 101, Sybase, Oracle, SQL Server, and DB2. You don't have to remember these, but if you're at a job interview and someone starts talking about their database, you might hear that they use one of these products. Before designing a database, database administrators plan what the data will look like and how the relationships will work. One tool used for this is an entity relationship diagram. An ERD tool typically has several visual cues that help you envision how the database will be formed. A primary key is often represented as a tiny gold key. The tables or entities are represented by a rectangle with a table name on top and the data or data attributes on the bottom. Lines are drawn between the tables to show the relationships of the data. There are 3 ways tables can be related: one-to-one, one-to-many, and many-to-many. Examples will be shown in the next 2 slides. This is an ERD showing the relationship between customers and orders. It has 4 tables for product, order details, orders, and customer. The product table has product ID as a primary key. To relate order details to it, we need to link it on product ID as the unique identifier. One product may have several order details associated with it because several different customers order the same products. So, the relationship is marked as one-to-many between those 2 tables. Similarly, one customer may have many orders, so that too is a one-to-many relationship. Here is a second example that I chose because it had a one-to-one relationship in it. This is an ERD for a bookstore. It's a little bit more complex than the last example, showing more detail in the attributes. Look at the title table in the center. The first attribute is a primary key, title ID, int 11. This is a unique number identifier for each book. Int 11 means it's an integer with 11 numerical placeholders. Varchar indicates a character data type. Data types of text and date are also in the diagram. The one-to-one relationship shown in this figure is at the lower left. It links author to obituary through the primary key, author ID. I'm not sure why a bookstore ERD needs an obituary table, but it does give us a nice example. One author would only have one obituary, so the relationship is one-to-one. We're at the end, so let's try to answer a few questions. Is last name a good primary key if you're just using a small database for a class? No, it really isn't. People often have the same last name. So it might be okay for your little class, but what if somebody joins the class? Or what if you use it for another class? It's not expandable to accommodate more students, and it's likely you would have a duplicate of last name. Name 3 tables that would be in a database for pet adoption. There's lots of tables you could probably figure out for that application, but let's try animals, the animals waiting to be adopted, new owners, people seeking a new pet, and shot history. Shot history would be what the different animals waiting to be adopted have as their medical record. What would the data attributes for a pet adoption database be for a table called animals? You can probably think of a lot of things for this table too. The answer I've got is pet ID, the primary key, and maybe you'd list the breed, the age of the animal, name, is it kid-friendly or not, is it friendly to other pets, the color of the fur, etc. That's it.